Last notes video of energy sources, and I'm sure you're dying to be done with this. So, where do we pick up? Well, like we left off in the last one, we need to pick up with this one with the geography. Now, unlike fossil fuels, geography is going to play more of an important role with renewables and where we can use them. Now, we can use most renewables wherever we want. However, there are certain parts of the country that are better for some than others. So let's take a look at it. The first one, according to your notes, is wind power. And wind is going to be the best used in the Great Plains, in the plain states in the middle of the country. Now, don't confuse this with the Midwest. The Midwest are places like Iowa and Ohio and Illinois. We're talking like Kansas, Nebraska, Texas. That's the plain states. The next one is hydropower. Now, obviously, hydropower is anywhere with a suitable sized river. You can make a dam and get your hydropower from there. But the easiest place to use this and the most productive, cheapest, all of that stuff that we actually care about is going to be near places with huge elevation changes or mountains. Really, if you just follow the mountains of the North American region, especially for us here in the United States, that's where you're going to find a huge majority of your hydropower plants. Now, what does that mean? Is that the only places we can use them? No, but that's where a lot of them are going to be located because it's the easiest and the cheapest. So it comes with no surprise then that geothermal is going to follow the same path. It's going to be best used where there's tectonic activity, where there's more heat that's going on underneath the ground. So where's the tectonic activity in the United States? Out west. In our western states, near Yellowstone and our national parks that are in Northern California and places like that. Now, we can use them here, and we even thought about using one here at Davie High School when we were originally building it. But ultimately, this one is more expensive. And like I told you with other ones, the cost has gotten pretty comparable to coal. So we don't really have to worry about the price too much, like once it's installed. However, geothermal can be a bit more expensive. So it's best used in places with tectonic activity where there's more stuff going on. And the last one, perhaps the most unsurprisingly, the best place to use solar power is in the desert, where it's sunny almost all the time. Doesn't mean it's hot all the time. The desert actually gets quite cold at night, but it's sunny a huge majority of the year. Turns out, if you go into the economics and the policy of it, which I'm sure all of you are going to run to go look up right now, that doesn't mean that that's where the most solar energy is used. And it turns out that that's not where a lot of renewables are used. It's not the states that have the most resources necessarily. It's the states that are set up the best governmentally and financially and economically. Kind of surprising? Not really if you're paying attention, but you're just now starting to pay attention, so I can forgive you this time. What do we use that for though? Well, electricity, right? However, we have to worry about two other things, and heat is a huge one of these. And what we have to really consider is, yes, we use electricity for things like this and lights, and we talked about this, and cameras and everything, really, plugging our phones in, plugging our laptops in, all of that. But heat keeps us warm in the winter, and if we didn't have that, it's going to be pretty miserable through those cold months. Natural gas is going to be the largest fossil fuel that we use for heat. However, that doesn't mean that it's not replaceable as well. As always, though, there's not one answer, and no one answer is going to be the best. So what do? First off, it's just biomass, just plain old burned stuff that was once alive, kind of like fossil fuels. However, this hasn't turned into fossil fuels, like trees and dung and things like that are kind of gross, but still renewable at least. That's never going to run out of that, unfortunately, or fortunately. But what you have to be careful with in biomass is that it's still burning something that was alive. It's still burning a carbon-based thing. It's still going to release CO2. And what you also have to keep in mind is if you're using trees, that you don't cut too many trees down too quickly, because then you're going to run into deforestation. And not only can deforestation cause, a lack of energy, or a lack of trees, or a lack of money, depending on which side you want to take of this, it can also have a lot of ecological things that go wrong with it, more than what you might think of off the top of your head. And we're going to get to that later when we get to biosphere, what happens when you have deforestation and you overuse the land. Maybe you've talked about it before, maybe you haven't, but it's more than just meets the eye on the surface level. So we can use the sun maybe. We've been talking about using the sun for solar panels why not use it for heating? Because, go outside in the summer, it gets pretty warm, or go outside in the winter and it keeps you from being absolutely frigid. We have two different things we can do here. We can use active solar heating and passive solar heating. Passive solar heating is the more simple of the two. It's a greenhouse. It literally just creates the greenhouse effect. Windows and ceilings are set up to be transparent, that lets the sun in, that lets that heat in, but it doesn't let it out, effectively warming up the area. Active solar heating is helping out other things like, water heaters. We're already preheating that water a little bit so that the other thing, whatever it might be, has to do a little bit less work. You can use this for cooking or cleaning or showering or whatever, but it's kind of taking a little bit of the electrical load off of that, or the natural gas load off of the energy use, and we're using the sun, which is renewable. It helps save a little bit. And as you've maybe seen, as you've gone through and looked at what's going on around your house and around the school, every little bit that we can knock out is going to be a bigger player later on, especially when we multiply it by hundreds or thousands or hundreds of thousands or millions or whatever of people. But none of this solves the transportation problem. And transportation is probably the one that we can see the easiest. Maybe you're not driving yet, but you had to drive to get here, or someone had to drive you to get here, or you got picked up in a bus which drove to get you here. And if you fill your gas tank up, or your diesel tank, or whatever, you're going to see the dollars kind of rolling through, and you're going to be aware of how much you're paying for that energy. So what do? Transportation isn't going away. The United States is not set up to have a public transit sector. That's a whole different topic. Alternatives. Once again, finding something to replace what we already have. The first one, the one that's kind of being pushed the most right now, are biofuels, especially ethanol. Go out to those plain states again, and we can talk about corn that is being grown. It might be for us to eat. It might be for animals to eat. It might be for ethanol, which takes corn and ferments it and uses it as a supplement and an additive to gasoline. Now, there's different grades and different levels and different qualities and all of this. But basically what we're doing is we're trying to take away that, high demand fossil fuel and replace it with something that's a little bit more sustainable. That's not the final answer though, because it's still using fossil fuels and we're still emitting a lot of pollutants. So what we might use next is something that was researched and hoped to be the next step in transportation, which is hydrogen. Hydrogen is the most commonly easiest found element in the universe, so why not use it? Turns out it's kind of expensive. It's difficult to separate, it's difficult to store, it's difficult to transport, it's difficult to refuel. And while the only thing that happens with hydrogen is that we get water vapor, H2 plus O2 gives you water through that easy chemical equation, it's still really expensive and difficult. So hydrogen's probably not the answer anytime soon. So then we go to the thing that's been popular the last 5 to 10 years, which are electric vehicles. And maybe these aren't the long-term solutions either. I don't know. However, if I had to guess, I'm going to say that EVs are going to be the next biggest thing to get us to our transportation needs. Now, of course, there's tons of problems with this, and you've talked about them and you've heard them, I'm sure. And maybe we've talked about them if you've asked me. And yes, there is a thing called range anxiety, and you can only go so far on a battery before you have to recharge it, which is the same thing as a gas engine. However, the problem comes into gas stations are everywhere, and Tesla supercharging stations aren't. Well, one, they're getting better, we're getting more of them, they're more spread out, especially as it becomes more economically viable going back to money. But also, there weren't a ton of gas stations at the beginning either. It's going to take a while to get this infrastructure built, whatever it might be, hydrogen, electric, something we haven't even thought of yet. It's going to take a bit before our whole system that we're used to moves to this new thing. But battery technology has drastically improved in the last 10 years. You can look at old early generation EVs from Tesla or Chevy or Ford or whoever it is your favorite car maker might be. And we've doubled and in some cases tripled what batteries can do, both, speed-wise and range-wise. But it all kind of comes back to one word. And this whole unit kind of comes back to one word. And it's not energy, and it's not money, and it's not economics, and it's not government, although those are all important. And you would think that energy sources, energy would be the word. But it's efficiency. It doesn't matter what we use. It doesn't matter what our fuel source is. It doesn't matter how we move it. It doesn't matter what the application is. Efficiency is the name of the game. The less you can use to do the same amount or more work, the better off we're going to be. The fewer resources you have to take to accomplish the same goal is going to be a net positive in the long run. Now, I don't know what the answer is going to be because, none of us know. But I know that efficiency is what scientists and engineers are working so many hours trying to figure out. What can we do that's the cheapest, the most clean, the most renewable, the most whatever to give us the same quality of life that we're used to? I don't know, but I do know just the end of energy sources. So get ready for your test. Ask me any questions, and I'll talk to you soon.